Okay, I'm going to do a problem here on page 269. This is number 43, which is a proof. So we're going to make the two-column proof. We're going to prove that the angle bisector theorem works without just stating it. So let's go back to looking at what our note says. The angle bisector theorem says if a point is on the angle bisector, so if I'm sitting here on this angle bisector, then it is equidistant to each side of the angle. So then we're going to prove why is this red line equal to this red line. Okay, if I'm on the angle bisector, why is this distance equal to this distance here? So that is what we're going to do. We're going to try to prove why is PB equal to PC. Why is this yellow line equal to this yellow line? Without just saying, hey, that's the angle bisector theorem. So let's just go, of course, with starting off with the given. We're just going to put PB is perpendicular to AB, PC is perpendicular to AC, and AP bisects, because we're talking about an angle bisector, bisects angle BAC. So BAC here is getting split in two, so that's given. The way we're going to prove that these two yellow lines are equal is not by just stating the theorem. We're going to prove that these two top triangles are equal, you know, side, 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 or side, angle, side, and then mention the fact that these two yellows would be equal because those are corresponding parts inside congruent triangles. So I see right angles, so I know that's one angle that's going to be equal, and I'll eventually put that in the notes. I see another angle here because that's what an angle bisector does. I definitely want to state that I've got another congruent angle there. And then I think I'm going to go right down the middle and go reflexive property on this one side. So let's do everything. Let's deal with these right angles first. First thing I'm going to do is say that these are right angles. So I'm going to say angle B and angle C are right angles. Never mention that they are right angles in the given. But the reason why they are right angles is because definition of perpendicular lines. You've got lines that are perpendicular, they form right angles. Okay, I never said that they're equal yet. So that will be step 3. I'm going to say angle B here, this right angle is equal to angle C, and that's because all right angles are equal. All right angles are equal. And so now I've got my first congruent part. I've got an angle there. I'm going to need more than that. Let's go to these angles over here. I can put a number there, or I'm going to just say BAP, this top angle, is equal to the bottom angle CAP, and that is because definition of an angle bisector. My writing's a bit messy. I apologize. That is another angle. So I've got a tick mark here, because you're on an angle bisector. I've got right angles. I need one more piece to the puzzle. I've got AA. I'm going to need a side here. So that will be AP is equal to AP. And that, of course, is the reflexive property. And then that should be enough to prove that the two triangles are equal. Tick, tick. I'm now going to say triangle on the top, BAP, BAP, is congruent to triangle on the bottom, CAP. And it will because of an angle, and then the side length. And then finally, since I've got two congruent triangles, those two yellow side lengths, PB is congruent to PC, these two yellows, because those are corresponding parts inside congruent triangles. Therefore, they are congruent themselves. And that is 43, proving why, if I'm on an angle bisector, why would those two yellows be equal? Okay, and now I'm going to do the other proof here, 44, and this is going to prove the converse of what we just did, the angle bisector theorem. So the converse would say, I'm equidistant. I'm point S and I'm equidistant. Well, then that means point S is on the angle bisector. That's what this theorem says. If I'm sitting here and I'm equidistant to the sides, then I must be on the angle bisector. Well, instead of just writing the reason why it works is because that's a rule, we're going to prove that this truly is the angle bisector coming down here. We're going to prove that SQ bisects it. And the only way we can prove that this line here bisects it is if angle 1 here is equal to angle 2. And that's what we're going to eventually do. But the way we're going to do that even is by looking at this picture here and going, well, if this top triangle is equal to this bottom triangle, then angle 1 is equal to angle 2 because those are corresponding parts. And of course, if angle 1 is equal to angle 2, then it must be the bisector. Okay, so that's the logic here. So it's going to be a little bit of a long proof here. We're going to first figure out why these two triangles are equal, and then we will go into CPCTC to prove why we have a bisector. First thing, of course, I'm going to do is write the given here. I've got some perpendicular lines. I've got something that is equidistant. SP is equal to SR. So if I'm looking at the two triangles, I already have one tick mark here. Okay. What I'm going to do next is I'm going to use this reflexive property QS, but I also want to mention that this is a right triangle. So I'm going to first mention that we have a right angle, angle P and angle R down here are right angles, because that's the definition of perpendicular lines. Definition of perpendicular lines. If you got perpendicular lines, you have right angles. If you have right angles, then you have right triangles. So that's what I'm going to say next. Triangle on the top, QPS, and triangle on the bottom, QRS, are right triangles. And the reason why they're right triangles, because of step 2, I have right angles. I'm just definition of a right triangle. A right triangle would have right angles. Okay? Now the reason why I want to have step 3 there is because I'm going to use hypotenuse leg. And the only way you can have hypotenuse legs is if you mention you've got right triangles there. So next, I've already SP, SR from the given. This is actually the leg. And I'm now going to say QS is equal to QS. And that is obviously reflexive property. And instead of putting an S for another side length, this is actually H for hypotenuse. Okay? And now I can say that because I've got the hypotenuse leg down, and I mentioned we've got a right triangle, I'm going to mention the top triangle is equal to the bottom triangle because of hypotenuse leg. Now I'm not going to say angle side side because that actually spells ass. If you say right angles are equal, then a side, that actually spells ass. So they're still congruent, but they're congruent by hypotenuse leg. Okay, so why did I try to figure out why those two triangles are equal? Because I want angle 1 to be equal to angle 2. And that is corresponding parts. Inside congruent triangles, we have congruent triangles, so therefore they are congruent. And if these two angles are equal, then this line QS must be the bisector. And that's what we're going to conclude with. QS bisects. And that's by definition of a bisector. I have two congruent angles, so definition of an angle bisector. If I have two congruent angles, then that is what a bisector created. Okay, and that is number 44.